Hello everybody, today we are taking a look at arithmetic series. Now I did a previous video on arithmetic sequences, and a sequence is where you are simply listing terms in a number pattern by separating them with a semicolon. Today we are talking about series, and what makes a series a series? It is when you can find the sum of a number of terms. So essentially, instead of having a semicolon in between the terms, we have pluses in between the terms. Sometimes we even have minuses in between the terms when our terms are negative. So here is an example. We have listed a few numbers here, and you can see that I've put pluses in between them. So I have 2 plus 5 plus 8 plus 11. Now, just like in an arithmetic sequence, in an arithmetic series, we have that same arithmetic thing happening. We have a constant first difference between all of our terms. In this case, we can see that the constant first difference is 3. So from 2 to 5, I'm adding 3. From 5 to 8, again, I'm adding 3, and so on. Now, whether it's a sequence or a series, it still has a constant first difference, so we can still use our TN formula if the question is asking us for a specific term. So for example, it can ask us for term 12 in this number pattern. We are then going to say that A is the first term, so 2 in this case, plus n minus 1, n is 12. So I'm going to do 12 minus 1. You are allowed to just write 11 straight away, and then multiplied by our constant difference, which is 3. And that will still give us an answer of 2 plus 33, which is 35. So even though it's a series, we can still answer questions about terms in the series using the TN formula. But now, since we are adding terms together, we have another formula that we need to be able to do, and that is the sum formula. So we use a capital S to represent sum, and then we say 2n terms, so we have our n as a subscript. Now, this is a formula that is on the formula sheet, so I'm just going to write that out for you, and all of these variables represent the exact same thing as in the previous formula. Again, n is the number of terms. So in this case, it will be the number of terms that we are adding together, that we are summing. We're finding the sum of a certain number of terms. So what do we get if we are adding, say, for example, 10 terms in this number pattern together? What will the total sum of those terms be? A is still my first term, so term 1 in the number pattern. N, again, is the number of terms, so I'll just put an arrow there. And D, just like in the previous formula, is still my constant difference, my constant first difference. So the variables don't change, it's just the formula that we are subbing into. Alright, so now, say we are finding the sum to 10 terms. I'll just show you how to use this formula. You are going to put whatever your n value is goes into the formula for n. So we're summing 10 terms, apologies. So we're going to do 10 over 2. And then we're going to have our square bracket there. We're going to say 2 times a, which again is the first term, which is still 2, plus n minus 1. So 10 minus 1. You can write 9 straight away. It's fine if you put 10 minus 1 in brackets first. And then the difference still is 3. You would then just type that into the calculator, and that will give you an answer of 155. Now, the important thing to remember about this formula is that this signifies the first 10 terms in the number pattern. It's not just any 10 terms, it is the first 10 terms. As soon as you see that SN, that notation, so S10 in this case, that is term 1 plus term 2 plus term 3 plus all the terms in between, and finally the last term that is being added to get that sum is term 10. There is another formula for sum to n, which is not on the formula sheet, and that is not as widely used, but I will do a separate video on that.